Okay, folks, this is the last topic, I think, for the year. It's a big old one, differentiation, and we're starting with the chain rule. So obviously we've done differentiation a lot in the previous year, and we've exclusively differentiated powers of x. And we've used this rule, that you multiply by the power and that you decrease the power by 1. So just to look at these as two little examples, if you had y equals 15x squared, etc., then our differentiation, so our dy by dx, we would times by 2 and decrease the power by 1. If we've just got an x on its own, then that essentially becomes 30. The x disappears. We're timesing by 1 and decreasing it to just x to the 0. And if you've got a number like minus 14, that goes to 0. So if we wanted to simplify this a little bit, we could. 2 times 15x, that's 30x plus 30. And there's other things we looked at in terms of turning points, but that basic idea is what we're going to expand on today. Let's look at another one here. We've got a fraction, and we couldn't really deal with fractions last year. We will be able to in a couple lessons, but not just yet. So what you had to do is make everything into a single power of x. So we had to rearrange this to being x cubed over x squared plus, and then let's write this as a power, x to the half over x squared, which is x plus x to the minus 3 over 2. Going to subtract our powers there. And so our dy by dx, well, x would go to 1, and this would go to minus 3 over 2 times by the power, and decrease to minus 5 over 2. So we could tidy that up to 1 minus 3 over 2 x to the minus 5 over 2. Now there's all sorts of ways of proving and looking at this, but I'm actually going to jump straight into it this week and we'll maybe come back and look at the proofs later. This is the chain rule for differentiation. And the basic idea is that if you can express a function, y, as a combination of two functions, f and g, then you can differentiate them both separately and multiply those together, and that'll give you your dy dx. Now I think when it's phrased like this, that maybe doesn't make a huge amount of sense, so we're going to use this as an example. Now I picked this one because it's one that in theory we could have done before, and we'll show that this new method gives the same answer. In the old days, for 3x plus 2 cubed, we would have had to expand this, so because we want everything as a single power of x. So if we did that, we would end up with 27x cubed. I had to pull out my binomial tables for a second there. 54x squared, 36x, and 8. That would be our y. If we differentiated that, then we would get 81x squared, 108x plus 36. Now with this new method, this is what we do. We say, okay, this looks complicated. So instead of saying y is equal to 3x plus 2 cubed, we'll just say that y is equal to u cubed, because we know how to differentiate u cubed. And then what is u in that case? Well, u is the thing that we're cubing. U is 3x plus 2. So according to our rule, if we want dy by dx, we need to find dy by du and du by dx. So let's do that. Dy by du, well, we just times by the power and drop the power. Du by dx, 3x will go to 3 and 2 will go to nothing. So if we multiply these together, we'll get our dy by dx, which is 3 times 3, so 9u squared. We can then substitute back in the fact that u equals 3x plus 2 and say we've got 9 lots of 3x plus 2 squared. Now is that the same as what we had before? Well, let's expand it and find out. You don't have to do this obviously, but it's worth pointing out that these are the same thing. So 3x plus 2 squared would go to 9x squared plus 12x plus 4, and if we expand times by the 9, we've got 81x squared plus 108x plus 36. They are the same. So yeah, the general idea behind chain rule is to make stuff which requires a lot of expanding a lot easier to do. So here are a couple of examples which are maybe a bit tougher. I'd like you to have a go at this, see what you come up with, and then unpause the video when you're done in 3, 2, 1. Okay, so let's have a look at these. You've always got to say what y is. So y is u to the power of 5. U is 2x minus 4. Differentiate them both. So dy du is 5u to the 4. Du dx is just 2. Multiply them together. We get our dy dx then is 10u to the 4. And then substitute back in our u that we found is 10 lots of 2x minus 4 to the power of 4. Okay, let's look at the second one here. Again, we're going to say y equals u cubed. We're going to say u equals 3x cubed minus 2x because that's what's inside our bracket. We're going to differentiate dy du is 3u squared. Du dx is 9x squared minus 2. Then we're going to multiply them together. So we're going to get that dy dx is equal to 3u squared, and then remember to make sure you keep this in a bracket because we're timesing the whole thing by 9x squared minus 2. And then we'd write in, well, we know what u is, so we're going to have 3 lots of 3x cubed minus 2x squared times 9x squared minus 2. No one promised the chain rule would be pretty, it's just very quick. What about this one here? Y equals 1 over 8 minus 4x. Well, that's the same as 8 minus 4x to the power of minus 1. Remember, if you've got 1 over something, that's a negative power. So we could say here that y equals u to the minus 1. U equals 8 minus 4x. We could differentiate them both, so dy by du is minus u to the minus 2. And du by dx is equal to minus 4. Then we could multiply those two together. Let's just separate this maybe. Multiply those two together and we can get dy by dx is equal to, well, minus times minus, so 4u to the minus 2, which is 4 lots of 8 minus 4x to the minus 2. And you could, if you want, even simplify that a bit more. We know that minus 2 as a power means over x squared, so we could write it like that. And then this last one is a similar sort of trick. If you've got a cube root, that is a power of a third. So we'd say y is equal to u to the power of a third this time, and u is equal to x to the power of 4 minus 3. And this is definitely something we couldn't have differentiated before. We can't expand this. Maybe we could do an infinite binomial series, but that seems quite complicated. So your dy du is a third u to the minus 2/3. Remember to decrease the power. Du by dx is 4x cubed. Multiply them together, we'll get dy by dx is 4/3 x cubed u to the minus 2/3. And then you want to substitute in your value of u now, so that would be 4/3 x cubed x to the 4 minus 3 to the power of minus 2/3. So there you have it. That's the basic use of chain rule, and if you pick up nothing else today, I think that's still a job well done. But we are going to expand on this a little bit. So what we're actually going to do is introduce a few more differentiation results. Now again, I'm not going to prove these today because I think we're going through quite a lot of things, but I'm going to introduce you to 3 standard differentiation results that you are meant to know in A-level maths. So the first one is differentiating sine and cos, and I've written it out here, and I'll keep this on the side of the page when we're using them on the slides. You've got if y is sine x, then dy dx is cos x, and if y is cos x, dy dx is minus sine x. Now this actually leads you to a little bit of a circle, because if you think about this, if we started with sine x and we differentiated it, we'd get cos x. If we differentiated cos x, well, according to this, we get to minus sine x. If we differentiate minus sine x, we're going to get the negative of what we get when we differentiate sine x. So we'd, instead of getting cos x, we'd get minus cos x. And if we differentiate minus cos x, we get the minus of what we'd get here. So we, instead of getting minus sine x, we get minus minus sine x, or just sine x. Now, I'm a big fan of this way of looking at the differentiation of sine and cos. Big fan of the circle of trig. But you can just use this if you want instead. Anyway, let's see how this works with the chain rule. So we've got y equals sine 8x here. So I'm going to say that y equals sine u. I'm going to say that u equals 8x. I'm going to differentiate them. So dy by du is equal to, let's see, sine x goes to cos x. So that's cos u. And du by dx, well, that just goes to 8. So our final differentiation would be 8 cos u, sub our value of u back into there, 8 cos 8x. Fair enough. Let's have a look at the next one. Our next one is y equals 4 cos u, and u equals 3x. If we differentiate this first term, we're going to get to, well, cos goes to minus sine, so we're going to get minus 4 sine u. Remember, the number at the front doesn't really do anything, it's just times by 4. And du by dx is equal to 3. So if we multiply those two together, we'll get minus 12, 4 times 3, sine u. And we can obviously sub in u is equal to 3x, isn't it? So minus 12 sine 3x. There we go. Let's have a look at the next one. Remember, if our power is written like this, it means that the whole thing is cubed. So we would break this one down as being y equals u cubed, where u equals sine x. And then let's do the same thing. So dy du is 3u squared. Du dx is cos x, because that's what sine goes to. So our dy dx is those two multiplied by each other, which would be 3 u squared cos x. We know u is equal to sine x, so that would be equal to 3 sine squared x cos x. Okay, and then one last one. We would say y is equal to cos u. We would say u is equal to 5x squared plus 2. We would differentiate them both. Dy du is equal to minus sine u, and du dx is equal to 10x, and the 2 goes away. Multiply them together to get our dy dx is minus 10x sine u, and then substitute in our value of u, which was 5x squared plus 2, to get this is minus 10x sine 5x squared plus 2. Okay, so I said there are 3 results that we're going to introduce. So that was our first one, that was for sine and cos. The next one is for exponentials. We actually mentioned this one when we did e to the x earlier in the year, that the whole point of an e to the x function is that its gradient is always the same as its y value. So if you differentiate it, you just get the same result. But I also want to introduce this second result here, which we are again not going to prove today. If you've got just any number to the power of x, then it differentiates to this form. So let's just see how that works. And again, let's try and get our chain rule in. So our first question, we've got y equals e to the 6x. So I'm going to say y equals e to the power of u. I'm going to say u equals 6x. I'm going to say dy by du is e to the power of u, because e to the x doesn't change. And du by dx is equal to 6. Multiply them together for our dy dx is 6e to the u. Sub in our value of u is equal to 6e to the 6x. What about the next one? It's another e. So again, we'd say y is equal to e to the u is equal to x squared. Differentiate them both. So that's going to give us e to the u and 2x this time. Multiply them together, we'll get our dy by dx is equal to 2x e to the u, and then sub in our value of u, that's going to be 2x e to the x squared. Okay, what about our next one? Well, this is using the second of our 2 rules. This is the one with a to the x. We're going to say that y is equal to 6 to the power of u, and we're going to say that u is equal to 2x. Now if we differentiate y, according to this, we end up with ax ln a. So we'll end up with 6 to the u times ln 6. and our du by dx will just end up with 2. If we multiply those two together, don't make this into 12 to the power of u. You can't multiply something with a power by just a number. This is going to be 2 lots of 6 to the u ln 6, which looks a bit nasty. This is our dy dx. We can sub in our 2x there, and we can say 2 lots of 6 to the 2x times ln 6. Let's look at another one. Again, this is e. Most of the ones you're going to see are e. I just wanted to point out that result exists. We've got y equals 7e to the u. You don't need to like put the minus in there. We want this to be as simple as possible. And we only know how to differentiate e to the x, so we want this to be e to the just one letter. U is equal to minus 5x in that system. Dy by du is equal to 7e to the u, because e doesn't change. Du dx is equal to minus 5. Multiply them together to get our dy dx is equal to minus 35e to the u, which is going to be subbing in our value of u, minus 35e to the minus 5x. And then our very last one, remember root x is the same as x to the half. We're saying that y is equal to e to the power of u, and u is equal to x to the power of a half. Let's find our dy du. That's just e to the u. Our du dx, that's a half x to the minus a half. Multiply them all together, and we're going to get ourselves to dy dx is equal to a half x to the minus a half e to the u. Sub in our value of u. This is a half x to the minus a half e to the x to the half. Now, if you really wanted to, you could, instead of writing x to the half there, we could write square root of x. And instead of writing x to the minus a half here, we could write 1 over root x. But, you know, no one's going to be giving you extra marks for that unless it requests it. And the third key result that we're going to introduce is probably the simplest. If you've got ln x, it differentiates to 1 over x. Let's see how that applies with chain rule. If we've got y equals ln of u here, u equals 4x, and dy du is just 1 over u, and du dx is just 4. Multiply them together, we'll get our dy dx is 4 over u, and then we want to sub in what we know, so this is 4 over 4x. It does actually simplify to 1 over x, which is cool. Right, what about our next one? Y equals ln of u, again. U equals 2x to the power of 5. Our dy du is 1 over u, again. Du dx is equal to 10x to the 4 this time. Multiply them all together, we'll get dy by dx is equal to 10x to the 4 over u, which is 10x to the 4 over 2x to the 5, and loads of that will cancel out. So we can cancel out the 10 with the 2 to get 5, and then this will just be over x, so 5 over x. What about this one? Y equals the square root of ln x. So in this case, we're actually going to say y is the square root of u, where u is equal to ln of x. We're going to differentiate them both. We're going to say this is a half u to the minus a half. We're going to say du by dx is equal to 1 over x, because that's our common result. We're going to multiply them together. Dy dx is equal to 1 over 2x u to the minus a half, which is 1 over 2x. What was u? U was ln x, wasn't it? So it's what? Ln x to the minus a half, but we could tidy that up a little bit. That's the same as 1 over the square root of ln x, so we could make this 1 over square root of 2x ln x. 1 over 2x times the square root of ln x. Okay, very last one. Let's introduce the circular trig again. Y equals ln u, u equals sine x, and then our dy by du is 1 over u, yet again, and our du by dx, or sine x, goes straight to cos x. we'd multiply those together as per. That would give us cos x over u, and then we'd sub in the u that we've worked out, so that is cos x over sin x. This does actually simplify a little bit more than that, but we're not going to do that today.